everyone. Today I'm going to tell you what is critical damp spring. So let me tell you what is critical damp spring. Critical damp spring is a spring that tries to maintain a certain length by exerting a force equal to the displacement from the length time with the spring constant. A damp spring is one that exerts an additional force proportional to how fast its length is changing in order to counter that motion. When a spring doesn't have much or any damping, it will oscillate. But if we get the damping just right, the spring will just decay back to its original length with no oscillation. So this is what we call critical damp spring.
My name is Amira. I'm going to explain about the equation of critical damp situation. So first, force of the springs that we use is F equals to negative Kx. Then the equation of the critical damp is Y equals to EAX A plus BX. And after that, we're going to derive as usual to obtain the general equation solution, which is Y equals to A plus BX EWX, where W is constant. Then I'm going to explain about the differences between under damp, critical damp, and over damp. So the equation for under damp is Y equals to AEM1x plus BEM2x, where over damp is Y equals to EAX A cos beta x plus B sin beta x. So now I'm going to explain the differences between these three equations, which is in this graph we can see that according to this graph, this is the under damp and this is critical, and lastly this is over.
Okay, now we will proceed to the example. Okay, the question is, show that the system y double prime plus 8y prime plus 16y equal to 0 is critically damped, and graph the solution with initial condition y bracket 0 equal to 1, y prime 0 bracket 0 equal to 0. Okay, the question is y double prime plus 8y prime plus 16y equal to 0. Firstly, we find characteristic root. Okay, bracket 8 power of 2 bracket equal to 4 bracket 1 bracket 16. We will get same 64 equal 64. Okay, and then we will find the root. Okay, so the root is same, m1 equal to m2 equal negative 4. Okay, we will use this formula. Okay, I will explain if we have a different roots. When we have a different root, we use this formula: AE power of mx plus BE power of m2x. Okay, when the root is similar, we use this formula. Okay, when we have a complete root, when we have a complete root, we use this formula. Okay, and then we find exponential solution. Okay, y equal to a plus bx bracket e power of negative 4x. Okay, the initial condition is y bracket 0 equal to 1, y prime bracket 0 equal to 0. Okay, we insert y 1. Okay, bracket a plus bx bracket e power of negative 4x, and then we will get a equal to 1. Okay, after we insert all of this. Okay, and then we differentiate. Okay, u equal to bx, we differentiate all of them. B equal to e power negative 4x, u prime equal to b V prime equal negative 4e power of negative 4x. We will get, after we differentiate, we get VE power of negative 4x minus 4BXE power of negative 4x. And then we differentiate again. Negative 4AE negative power of negative 4x plus bracket BE. And then we differentiate again. Negative 4AE negative power of negative 4x plus bracket BE power of negative 4x negative minus 4BXE power of negative 4x. And then we will get the B after we insert this condition. Okay, because the rules are repeated, the system is critically dampened. The initial conditions are satisfied when A equal to 1, B equal to 4. So this is the formula. Okay, this is the graph critically dampened.
I'm Danisa Kumang Anarone, and today I'm going to explain the applications of critically damped oscillation. Okay, the first one is a car suspension. When we drive over a bump, the shock absorber of the car will absorb the shock, the force due to the tire of the car hit the bump. In this situation, we don't want our car to oscillate because it could lead to uncomfortable condition to us and it can cause the loss of control of the car. Thus, we want our car to return to the equilibrium position without any oscillation. Okay, the second one is automatic door closer. When we close the door, we close the automatic door, it will close immediately without having any oscillations. Hi, it's me again, Danisa Kumang. Okay, today I'm going to explain the benefits of the critically damped oscillations to our daily life. Okay, the first one is critically damped system is used to reduce the effect of earthquake to a skyscrapers. It gives time and easier to us to escape from the building without having a large impact due to earthquake. Okay, the second one is to protect fragile products in manufacturing of products.
As a conclusion, critical damping gives some advantages to us. For example, it can avoid number of oscillation. Let me tell you the application that can be used in our real life for critical damping. For example, instrument like balance and electrical meter are critically damped so that the pointer can move faster to the right position without oscillating.